This is Mr. Martin. This video is section 1.2 in Honors Geometry, talking about measurements of segments and angles. We're going to look at a bunch of definitions today too, and the correct form for those definitions for our class. So a lot of these terms you already know. We're just going to rewrite them in a little different way that's a little bit more specific for our class. So the first one we're going to look at an acute angle. So I'm sure you all know what an acute angle is. But notice how I have this written. It says if an angle is acute, then its measure is between 0 and 90 degrees. So you notice we have this in if-then form. It's a conditional statement. And almost all of our definitions, especially for the first few months of school, we're going to write them in conditional form. So you want to make sure it's if something, then something else. And again, you'll notice the term also that we're defining, acute, is in what we would call the hypothesis, the part that goes after the word if. So if an angle is acute, then, and then we give the definition, and its measure is between 0 and 90. And any definition, and we'll talk about this a number of times, we say it's reversible. And when we say it's reversible, that means that its converse is true. So this is an important concept here. Again, we'll talk about it more soon. So any statement written in conditional forms, any statement written in if this, then that form, we can write the converse, but the converse may not always be true. And we'll look at some examples later of when the converse is not true. Maybe you want to think of one and bring it to class with you. But if a statement is a definition, then its converse is always going to be true. Okay, so if the converse is true, again, we say it's reversible, or another fancy word, we could call it biconditional. So those are some things to remember. You might want to just jot a couple things down about it. So the converse of our definition of acute angle, we're going to switch the hypothesis. So our hypothesis here was an angle is acute, and our conclusion was its measure is between 0 and 90 degrees. So to get the converse now, we're just going to switch these two parts. So you'll notice in the statement, if an angle measures between 0 and 90 degrees, then it is an acute angle. And you know, sometimes when we're writing it in English, you know, you have to adjust the sentence a little bit appropriately so it makes sense. Alright, so we're going to go through and we're going to write the rest of these definitions and their converses. I'm going to type these in so it's going to go a little faster. Pause when you need to, and write down questions as you have them. Alright, so for a right angle, we've got if an angle is a right angle. Notice we've got the term in the hypothesis, the stuff after the word if. If an angle is a right angle, then its measure is 90 degrees. Okay, then we're going to go ahead and write the converse. If you want to pause the video and see if you can write the converse on your own, that would be great. So the converse would be if an angle measures 90 degrees, then it is a right angle. So again, some definitions, you know what they are. We're just writing them again in a way that's going to be appropriate for our class. Okay, again, if you want to pause the video and see if you can write the definition and the converse for obtuse angle, we've got if an angle is obtuse, then it measures between 90 and 180 degrees. And then we'll go ahead and write the converse. If an angle measures between 90 and 180 degrees, then it is obtuse. Alright, moving on. Again, pause when you feel you need to. The next one, you probably have heard of a straight angle. I think we talked about it in the last video. Anyway, a straight angle is basically a line. So when we put a point on a line, it divides it into two rays, and then the angle between those two rays would be 180 degrees. So if an angle is a straight angle, then it measures 180 degrees. And feel free to use the degree symbol. I'm just not, because it's easier to type it in right now. Again, feel free to pause if you want to try the converse on your own. If an angle measures 180 degrees, then it is a straight angle. Alright, so these are our definitions for our angles. Now we're going to move on to the definition of congruent angles. So congruency is like the equality of geometry, and we're going to use the word daily probably for the rest of the school year. So if angles are congruent, then they have the same measure. So pause if you want to see if you can write the converse. If angles have the same measure, then they are congruent. Alright, so that's for congruent angles. In order for them to be congruent, they have to have the same measure. Okay, and now moving down here to congruent segments. If segments are congruent, then they have the same length. So again, we'll write the converse. If segments have the same length, then they are congruent. Okay, so finishing up here, we've got some notational things. You know, some of these are kind of specific to our book, but we're going to hold to these conventions. So you have to be really careful how you write things, because when we take the quizzes and tests, I'm going to hold you responsible for knowing the correct notation. So when we have congruent angles, we're going to write it like angle A congruent, notice my congruency symbol, angle B. So we're talking about two angles, and we're saying that these angles, the figures, are congruent. Okay? And then if we're talking about the measures of the angles, so let's say angle A is 50 degrees and angle B is 50 degrees, they have the same measure, then we would write the measure of angle A is equal to the measure of angle B. Okay, so notice here we have an equality sign, and here we have our congruency sign. So just make a little note here. Congruent. Okay? Alright, and then two different ways that we can talk about angles. Angles can be described in degrees, so we would say angle A equals 50 degrees, or if we talk about the angle in terms of its measure, now these are very similar. You know, again, it's just a notation. We would say the measure of angle A is 50. So if you want to remember or think of an easy way to remember how to keep these two different notations separate, you either put the degree symbol or you put the M for measure. Okay, but you don't put both. Alright, so lastly, let's talk about tick marks. Tick marks are just little marks on diagrams that we use to show that segments or angles are congruent, and we're going to use them all the time, and I strongly recommend that you use them. We'll be using them all the time. So let's say I have two triangles. Let's say this is triangle ABC. And then I have another triangle over here. Let's call it DEF. Okay, and if these two triangles happen to be congruent, Then I could mark the parts that match up, called corresponding parts. It's a little preview of things to come. I can mark the parts that match up with tick marks that are the same, and that's an easy way to visually see what's congruent. So if I put a tick mark over here like this on AB, I would put the same tick mark over here for DE to show that those two segments were congruent. Okay, so I could use two little marks, and then I would put two little marks over here. I could use a little circle to show that those were congruent. Really, whatever you want to use, be as creative as you want to. We could do the same thing with angles. So if I'm talking about angle A, I could go like this, and then that would be congruent to angle D, so I would put a tick mark that looks like that. You know, or you could do something like this to show that angle B was congruent to angle E. So, you know, whatever you want to use for your tick marks, it's just a quick visual way to see what parts are going to be congruent for you. Don't quite remember what problem 5 on page 14 is, but it says to study it carefully, so make sure you do that. And as always, if you had questions about anything we did, make sure you mark those in the margin and ask me the next time you see me in class.